Okay, moving on to the last question in the lift topic sheet. You have one end of a light inextensible string attached to a lift, and the lift goes over a smooth pulley and attaches to a block which is on top of a smooth inclined plane. So let's try and get all the information from here into this diagram. I'm told that sine alpha equals 3/5, so if that's alpha there, opposite over hypotenuse equals 3/5. So it's clearly a 3, 4, 5 triangle. I may need that later on. Now it then says that block Q has mass 5 and block R has mass 10. So if I just consider that as a particle, a normal pulleys question, then the weight there is 15g. I may need later on a bigger diagram, so let's do that over here and say that I've got R there and Q there. And let's just remember that this one's 5 kilograms and this one's 10 kilograms, and there's probably some tension there, so it's a zoomed in version of that. Let's read through all the other information. The whole thing is released from rest, and I want to find out what the acceleration is. So first things first, the acceleration, because this is 15g and this here is 5g, and actually the component of 5g that's acting against the tension is going to be even less than that, then this system is definitely going to accelerate in that direction. So I can now assume that the acceleration is that way. And in actual fact, I could have, if I got that wrong, it didn't matter, because if I assumed the acceleration was the other way, I would have just come out with a negative value for my A. The thing I can't do is assume that they're both accelerating towards the pulley or both accelerating towards away from the pulley. They're going to accelerate like this. So let's put in the tension, and I've also got a normal reaction on this thing, and there's no friction, and that's why actually, even if I got that wrong with the acceleration, it still works. If there was a friction and I assumed it was accelerating that way, then the friction would be this way, and actually it was accelerating that way, then the friction would be that way. I'd be in trouble. Because it's smooth, I don't really have to be too worried about getting it right in the first place, even though I did worry about it in a way and still figured it out that 15g is bigger than 5g cos alpha. So let's just do part A as a normal pulleys question, and I'm going to take up the plane to be my positive direction for particle P, and I will have the resultant force equals the mass times acceleration. The resultant force is T take away 5g sine alpha, because that's cos alpha, that's sine alpha. We know alpha is the angle in there, and that's going to equal the mass, which is 5 times by the acceleration. Clearly I have two unknowns there, so I need to work out that tension is going to equal 5a plus this. Now sine alpha is 3/5, so 3/5 of 5 is just 3, so 3 times by 9.8 equals 29.4, and that is my first equation. I'm going to get my other equation by resolving on the lift, and I'm going to take down to be positive because it's accelerating down. I could take up to be positive, and then when I get to the MA, I take the acceleration to be negative A. But generally it's better to take your direction of acceleration to be positive. So then 15g take away the tension is going to equal the mass, which is 15 times by the acceleration, and I can rearrange that to have T equals 15g. What is 15g? 147. Take away 15a, and then I'm just going to substitute my T from B into equation A, and I'll have 147 take away 15a equals 5a plus 29.4. That means my acceleration, let's put that on the left hand side, that means my acceleration is going to be that, take away that, divided by 20. So 147, take away 29.4, divided by 20. And I get an answer of 5.88 meters per second squared. And therefore, the tension, if I substitute into here, is just 5 times by that answer, plus 29.4, which is 58.8. So I should probably show that in my working. 5 times by 5.88, because that's probably going to get me a method mark. 58.8. Okay, right, next part of the question. Part B, find the magnitude of the force exerted on block Q by block R. So this is now the lift parts, and we want the magnitude exerted on Q by R. So we're actually looking for this normal reaction, but we know there's an equal and opposite normal reaction there. And if I know that the weight of this one is going to be 5G. And I know there's going to be tension, there's going to be a normal reaction there and that there, but we're getting to the point where we can just quickly work out what we want to work out without having to do too much extra work. I'll see if I can fit it into this part of my page. If we resolve taking down to be positive, and I'm resolving on Q, then I get the only forces acting on Q are the 5G down and the R upwards, so it's going to be 5G, take away that R, and that's going to equal a mass of 5 times by an acceleration of 5.88. So R is going to equal 5 times by 9.8, let's say 5G, take away 5 times by 5.88, so 9.8 take away 5.88 equals something, times it by 5 equals 19.6 newtons. I probably should have put newtons back here, shouldn't I? And the last part of the question, part C, find the magnitude of the force exerted on the pulley by the string. Okay, I'll do another little diagram over here. So there's my pulley. The pulley has the string over it here and the string here, and that should be the same tension. Now if I extend this out, I know that this angle here is going to be alpha, so that I know that this angle in here is going to be 90 minus alpha. Let's call this angle theta, where theta equals 90 minus alpha. So this is part C. The magnitude of the force exerted on the pulley by the string. So the string is the pulley is being pulled down that way and pulled that way. There's two ways I could do this now. I could take this tension and transfer it across and think, instead of two pushes at the same time, I've got, or two pulling forces at the same time, I've got a pull there and then a pull there, and then just find that resultant force. Or I could just think, what is the component of this force in this direction, and what is the component of this force in this direction? And the easiest thing to do, I would say, is we know that T is actually 58.8 here. And T is 58.8 here. So let's just imagine, let's just work out the component of this force and then the component of this force. So it's going to be twice, because it's a similar situation, right? We have a right angle triangle in here, and this angle here is half of theta, so half of 90 minus alpha. And we want to just work out twice of that. So the resultant force acting on the pulley is 2 lots of this force. Okay, now this force is just 58.8 cos of this angle, which is 90 take away alpha over 2. And what is cos of 90 take away alpha over 2? Half of that angle. There's no nice way of working out, I don't think. So all I'm going to do is making sure my calculator is in degrees. I'm going to work out alpha because sine alpha is 3/5. So alpha is 36.8. 90 take away that gives me an answer of 53, and I divide that by 2. So this angle here is 26.565 degrees. Okay, so take that answer, put it into here. So that angle there is 26. So this, the component of this part of the tension, the component part of this tension is 58.8 cos of 26 degrees. But we also get the component of this force, which is also 58.8 cos of this force, because we're just making a right angle triangle there, and because it's the same, we just times it by 2, so it's 2 times by 58.8 cos of that angle. So 2 times by 58.8 cos of that angle, which gives 105.18 newtons. 105, 3 figures, 105 newtons.